So hello everybody, today we're going to be doing an indefinite integral. So namely it's the integral of dx over the square root of 2x squared minus 6x plus 5. First of all, let's just try and use the quadratic formula right here. So maybe we can split this up. Let's see where that gets us. So 2x squared minus 6x plus 5 is equal to 0. By using the quadratic formula, we'll get that x12 is equal to 6 plus or minus the square root of 36 minus 4 times 2 times 5 minus 40, everything over 4. But the discriminant is less than 0, and we want to keep this problem in the real world. So this tells us that this approach won't help us. What we can do instead is we can rewrite this integral in some other way. Okay, so I'm just going to rewrite this at first. Minus 6x plus 5. And this is really the same as 2x squared times, okay, not times, but minus 2 times 3 times x plus 5. So this is a way of completing the square. So 2x squared minus 2 times square root of 2x times, what can we rewrite this as? Times the square root of 3 over 2. Oops, times 3 over the square root of 2 plus 5, and this is equal to 2x squared minus 2 times square root of 2x, and I'll just put that in parentheses, and times, when we rationalize this other factor, times 3 times the square root of 2 over 2 plus this here quantity squared. That's just going to be equal to 9 over 2, 9 over 2, and since we have a plus 5 right here, we also have to add 1 over 2. Great, and now this can be rewritten as the square root of 2x minus 3 times the square root of 2 over 2, everything squared, plus 1 over 2. Okay, and now that we know this to be true, we can just take out the 1 over 2 in front of everything, and we'll get square root of 2 times x minus 3 times the square root of 2 quantity squared plus 1, or when we factor out the square root of 2 from right here, we'll get the square root of 2 squared, but yeah, that won't help us in any significant manner. Okay, now that we know this, so this here is the same as this here. Okay, so now that we've completed our task of transforming this subintegral form, we can actually rewrite this integral as the integral of dx over 1 over 2 times the square root of 2x minus 3 times the square root of 2 over 2 quantity squared plus 1, which is the same as 2 integrals of dx, and of course everything is under the square root, so this will be the square root of 2 times the integral of the square root of the square root of x minus 3 times square root of 2 and we mustn't forget the 2 right here, and it's also here, and it's also here, and this is squared plus 1. Now we have this form that's just begging us to use some kind of sub. Okay, some kind of substitution. So I'm just going to go ahead and say that the square root of actually, before doing this, I'm just going to rewrite this one more time, which is equal to the square root of 2 times the integral of dx over, and I'm just going to plug in this 2 right here, so that's going to be the integral of 2 times x minus 3 squared plus 1. Yeah, this is a nicer form then. Okay. This is a lot nicer form. And I'm going to use the obvious substitution. I'm going to say that 2x minus 3 is equal to t, or 2 times dx is equal to dt. In other words, dx is equal to dt over 2. I'm going to factor out the 2 right away. So the square root of 2 over 2 times the integral of dt over t squared plus 1. Okay, and this is a pretty nice integral, I'd say. So how would you go about solving this problem? How would you go about solving this integral? Well, we can do something more. We can actually use a hyperbolic substitution. So we know that the hyperbolic cosine of x squared minus the hyperbolic sine of x squared is equal to 1. So from here we get that the hyperbolic cosine of x squared is equal to 1 plus sine hyperbolic sine of x and everything squared. So I'm just going to say that t is equal to hyperbolic sine of another variable, let's say z. And once we differentiate both sides, we'll get that dt is equal to hyperbolic cosine of z dz. So we get square root of 2 over 2 over times the integral of the hyperbolic cosine of z dz over the square root of hyperbolic sine of z, and of course squared, plus 1. And this here is the hyperbolic cosine squared. Once we take out the square root, we're just going to be left with with square root of 2 over 2 times the integral of dz, so which is the same as square root of 2 over 2 times z plus c. And then we have to go back to our original variable. So this is equal to square root of 2 over 2, and z is equal to the inverse hyperbolic sine, the area hyperbolic sine of t. So sine hyperbolic to the negative first of t plus c, and this is equal to the square root of 2 over 2, and remember that t is 2 times x minus 3, inverse hyperbolic sine of 2x minus 3 plus c. So this is our final answer to this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.